So today our topic is Thevenin's theorem. So what is Thevenin's theorem? Thevenin's theorem states that any two bilateral linear DC circuit containing several voltage and resistances can be replaced by an equivalent circuit consisting of a voltage source and a series resistor connected across the load. In other words, it is possible to simplify any electrical circuit, no matter how complex, to an equivalent two-terminal circuit with just a single constant voltage source in series with a resistance connected to a load as shown below. So this is the explanation of Thevenin's theorem. So here we are considering this circuit. Here there is a source, that is Vs. There are four resistances connected, R1, R2, R3 and RL, that is the load resistance. So let us consider a simple DC circuit. So this is the DC circuit. In order to find the equivalent voltage source, RL is removed. That means the load resistance. This is the first step. So here load resistance is removed first. Then we have to calculate the open circuit voltage or Thevenin's voltage in this end, in this terminal. That is A and B terminal. So in this circuit here, open circuit voltage, that is VOC, it should be equals to I into R3. So whatever the voltage drop across R3 should be the open circuit voltage. R2 is not considered here because when the circuit is open, so R2 will tends to 0. That's why we are considering the voltage drop across R3. So it will be I into R3. So whatever the value, I value should be equals to open the total voltage divided by the total resistance, that is R1 plus R3 total into multiply by R3. That should be the open circuit voltage value. Next step, now we have to find the internal resistance of the circuit, that is Thevenin's resistance or equivalent resistance. That is in series with the open circuit voltage VOC. Okay, so that is also called VThevenin. So now for that reason, we have to deactivate all the sources. If there are voltage sources, that should be shorted. If there are current sources, it should be opened. So we have to short the voltage sources and we have to calculate the equivalent or internal resistances. So from this load end, we have to calculate the RTH. So RTH therefore equals to R2 plus R1 R3 by R1 plus R3. Why this one is? Because R1 and R3, these two are parallelly connected when we consider from this end. And R2 is in series with these two. So that's why R2 plus R1 R3 by R1 plus R3. And the last step, we have to draw the equivalent circuit where there are VTH, there are in series RTH, and we have to connect the load resistance RL. And finally, we are calculating the value of I, that is the load current. It should be equals to VTH divided by RTH plus RL. So these all are the steps of Thevenin's theorem. So where VTH is the Thevenin's equivalent voltage. It is an open circuit voltage across the terminal AB known as load terminal. RTH is the Thevenin's equivalent resistance as seen from the load terminal where all the sources are replaced by their internal impedances. And RL is the load resistance. So here is the first example of Thevenin's theorem when we consider only DC. So here the circuit is given. You have to find the current through 10 ohm resistance. So here R1 is given 2 ohm, R2 5 ohm, R3 1 ohm, R4 that is 10 ohm, this resistance. This is now my load resistance. So first step, we have to remove the load resistance and we have to calculate the open circuit voltage across this end. So now we are using nodal analysis method. So here in this node, if we consider this C node, Here we can see that I1 is entering, I2 is existing current. So I1 plus I3 should be equals to I2, or I1 plus I3 minus I2 equals to 0. So by nodal analysis, we have to put the value of this current. So here we will get that V1 minus VOC, V1 minus of VOC divided by R1 plus V3 minus VOC by R3 minus VOC plus V2, VOC plus V2 by R2 should be equals to 0. So now we have put the value of V1, V3 and V2. So we will get that VOC equals to 13.29 volt. Now we have to calculate the internal resistance. So we are removing all the sources. So here in this case, 2, if we consider from this terminal, then 2, 5 and 1. These 3 are parallelly connected. So here, if we can calculate it, then we'll get that RTH equals to 10 by 17 ohm. Now finally, we are drawing the Thevenin's equivalent circuit where VOC is in series with RTH and RL, and we'll get the value of IL, that is 1.26 ampere. So next one example, here there is another example is given. This is the circuit we are considering here. We have to find the power loss in 1 ohm resistor by Thevenin's theorem. So here we are removing this 1 ohm resistance and we have to calculate the open circuit voltage. Again, we can apply KCL at node A. This is the node A we are considering. So here, if we consider this one, then we can get that VOC by 5. That means this one plus VOC minus 10 by 10. We are considering this branch should be equals to 2 because 2 is the incoming current. So then we'll get that VOC equals to 10 volt. After removing all the independent sources, we'll calculate the value of RTH. So RTH will be, it can clearly see that this 10 ohm is parallelly connected with 5 ohm resistance. So we will get that RTH equals to 3.33 ohm. And finally, we are drawing this equivalent circuit and we are calculating the value. That is power loss in 1 ohm resistor, that is 2.31. That is we are getting it this is the value of ITH. So ITH squared into 1 ohm resistance. So we will get that 5.33 watt. So next example, which is in 2017 GATE question we are getting. So here the circuit is given. This is 10 ohm resistance. There is a voltage source connected. This one is 10 ohm. There is 2 terminal open, that is A, B. Here it is 10 ohm. Here it is 5 ohm. And this one is 6 ampere. So you have to find the open circuit voltage across this AB terminal. That is the question. So what will be the first step? First step, what we can do is, this current source is parallelly connected with 5 ohm resistance. So we can use source conversion method. So five ohm, and here we'll get the voltage source, that is the direction of current is in downward side, so it should be negative, positive. It is 30 volt. There is 10 ohm. This is open terminal A, B. Now we can do what? That this resistance, these two resistance is connected basically parallelly according to this open terminal. So we can connect these two resistance parallelly. This one is 10 ohm. This one also 10 ohm. And what we can do, that these two resistance, this resistance and this value is in series, the voltage with the resistance are in series. So we can convert it by source transformation. We can convert this 16 volt in current source. So we are connecting this one. This we are converting this one as current source by source conversion method. So what will be the value of the current? So the value of current should be 1.6 ampere. So now this 10 ohm and this 10 ohm, these are parallelly connected. So we can draw the next circuit. This 5 ohm and 10 ohm, this also in series. So we can finally draw the circuit, that is 15 ohm is connected with 30 volt. There is an open terminal A, B. Next step, these two are parallelly connected, 10 ohm and 10 ohm. So what will be the resistance value? That should be 10 into 10 divided by 10 plus 10. That should be 5 ohm. So we can draw the circuit. Five ohm is in parallel with is in parallel with 1.6 ampere. Now again we can use source transformation method. So it will become 30 volt, 15 ohm, And again, this one, if we consider, so it will become 5 ohm. Is in series with 8 volt. 1.6 into 5, so it will become 8 volt. This is the AB terminal. So what will be the value if we consider this one circuit? So if we consider this node as VAB, then VAB plus 30 divided by 15 plus VAB minus 8 divided by 5 should be equals to 0. So from that we can calculate VAB. So VAB will be equals to minus of 1.5 volt. So this will be the answer. So okay, I'm just I'll just close this one. Okay, thank you.